Hello everybody, welcome to topic number 19, simplifying complex fractions. In this video, we're going to show you how to simplify a complex fraction by simplifying the numerator and denominator and then dividing. We're going to simplify complex fractions by multiplying by a common denominator, and we're also going to teach you how to simplify expressions in complex fractions that have negative exponents in them. A rational expression whose numerator, denominator, or both contain one or more rational expressions is called a complex fraction. Now don't forget, a rational expression is basically a fraction that has polynomials in both the numerator or the denominator. So in this case, when we contain more than one of those, it becomes a complex fraction. And again, we're going to use a lot of our skills that we've learned throughout to solve these. So they say here, consider this fraction problem. How would you go about simplifying it? So when we took a fraction, all we would do is go through and try to do skip, flip, and multiply, right? So we would take 3 over 20, and we would multiply it by the reciprocal of this. So it would end up being 12 over 5. And then we would look to see if we could simplify anything. And we would know 12 over 20 could reduce. They could both go into 2. So here I would have 6 over 10. And again, I can look to reduce. The 6 over 10 can actually reduce further because 2 can go into each of those. So 3 over 5. And we would multiply what we have left. And we would get a final answer of 9 over 25. And that's essentially what we're going to do here with our complex fractions. We're going to remember our rules of skip, flip, and multiply, and then remember things like how to find common denominators when we add and subtract rationals. So here's the steps we're going to follow. We're going to simplify the numerator and the denominator of the complex fraction so that each is a single fraction. This is only if needed. If it's already a single fraction on the top and the bottom, we don't need to do anything, but if we have multiple fractions, we will combine them and make them into one. We'll then perform the indicated division by multiplying the numerator by the reciprocal of the denominator, and then we'll go through any simplifying we need to as we do it. So let's start here. Here's a complex fraction that has monomials in all the parts. So what we'll do, we're going to keep the first part. We're going to change the division sign here to a multiplication, and then we're going to take the reciprocal of the bottom. So we're going to flip it, and it will become 9 over 15k. And then our job is to see if anything cancels out. We notice right away the k's will cancel out. 5 over 15 can reduce. We can remember 5 over 15 can become 1 over 3 if I reduce them by 5. So this will become 1, and this will become 3. And then here 9 over 36 can reduce. We know that 9 can go into each of these, and it will reduce to 1 over 4. So this will become 1, and this will become 4. So at the top, I have basically just left with 1. And at the bottom, I have 4m times 3. And 4m times 3 is 12m. So this fraction would reduce to 1 over 12m. Here we're going to do it again. This time we don't have monomials in the denominators, at least. We have binomials, but there's nothing that really needs to be simplified here. So we're going to do it by the same process again. We're going to keep the top part, and we're going to take the bottom part and flip it after changing it to a multiplication. So we'll take a multiplication, and this will become x plus 4, and this will become 3. We'll look to see if we can cancel things out. We will not cancel out x plus 4 and x minus 4. They're not the same because here I have a positive 4 and a negative 4, and they're not opposites because this is positive x and this is a positive x. We can't cancel out this x with this x because the bottom x is attached to the minus 4. And if I look at the numbers, 8 over 3 don't simplify. So really not much left we'll do with this problem. We'll write it as 8x, x plus 4, over 3, x minus 4. And since we can't simplify it any further, this would be our final answer. Here's a little bit more of a complex fraction problem. Now we notice the top and the bottom both don't have one fraction. Our goal is to make it into one fraction to be able to do this. Well, in order to do this, we need to take this fraction and combine it. So we're going to need to make sure we have a common denominator here if we do it. So we've got to find the least common denominator of the bottom. I have an a and an a squared. I could have one a here and I can have two a here's. We always keep the highest one here. So my LCD is going to be a squared. So I'll put an a squared here. I'll notice that the 5 only had the a with it. It only had 1, so I'm going to put another 1 with it. And then the b already had a squared with it, so the LCD is already our denominator. So this can just stay as b here. Now, this is one single fraction. We're going to do the exact same to the bottom. It's two fractions here. We're going to combine it into one. I have a b squared and a b. We always keep the highest exponent as our LCD. So in this case, the LCD is going to be b squared. So I will write b squared down here. And then we'll go back and see which part was missing what. So in the first fraction, it was already b squared. So nothing changes from the LCD. So I'll need to keep the 5a there that's with it. And then here I only had a b when I really needed b squared. Well, in order to get b to be b squared, I need to multiply this by b. So I'm going to go through. I still have a plus sign. And now it's just going to be 1 times b, which is just simply b. So now we've taken this, and we've taken these two fractions, and we turned them into 1. And same on the bottom, we took the two fractions and turned them into 1. Now we're ready to go through and do our skip, flip, multiply. We'll keep the first exactly how it is. We'll change the division bar here to multiplication. And then we're going to flip this guy. So it's going to be b squared over 5a plus b. And when I do that, I notice I have both 5a plus b on the top and the bottom. So they'll cancel. I'm left with b squared over a squared. And since these aren't the same base, I can't subtract out the exponents. So we would leave it b squared over a squared. One final problem. And this problem's a little bit trickier because it has negative exponents. So we've got to go back and remember our negative exponent rules. Anytime we have a base that's taken to a negative power, we simply rewrite it as 1 over x to that power. Or, if we have 1 over x to a negative number, it simply comes back up to the top and becomes x to that power. So essentially, we're going to take all of these negative exponents and we're going to turn them into positive exponents because we can't simplify it without it. We're going to take the breaks at the plus and the minus sign. So we're going to look at this as 4 different terms. So for example, I've got term 1 here. Now this is a negative exponent, so we need to change it to a positive exponent. It's x to the negative 1, so I will change it to 1 over x to the first power, or just 1 over x. Then plus. Then we're going to take a look at this second term here, and this second term only has the y to the negative 1 to the first power. So the 2 and the x can stay where they are, so we'll keep them at the top. And now the y is going to go down to the denominator. And so this will come down as y. We'll put this as our big division sign. Next, we'll look at the third term, which is just x to the negative 2. This has a negative exponent, so we're going to bring it down to the bottom. When we bring it down to the bottom, since there's no other terms there, we'll put a 1. So this is 1 over x squared plus, minus in this case. And now we'll look at the last term. We've got x to the negative 2 and y to the negative 1st. Both of these are going to have to come down to the bottom. And since both of these are getting circled, it means I have nothing left on top. So I simply have a 1. Now, it's all written with no negative exponents. So we can go through and begin the process of trying to simplify this complex fraction. We notice that both the top and the bottom have 2 fractions. Our job is to get it to be 1. For the LCD of the top, I have an x and a y in the denominator, so I need to include both in my LCD. So I will have an x and a y. Well, the first fraction here in blue had the x, but it didn't have the y. So we're going to do 1 times y, which is just simply y. Plus, now for the second fraction, it had the y from the LCD, it didn't have an x. So it needs to be 2x times the x, which is going to give me 2x squared. Now this numerator has become 1 whole fraction. A big division sign that we'll do here. And now we're going to work the same from the bottom. The LCD here, both terms have an x squared. And this one also has a y, so that has to be included in my LCD. So my LCD is x squared and y. For the fraction in red, we have the x squared part. It doesn't have the y. So I'll need to do 1 times y here to give me a y. Finally, for the last one, I already have the LCD as my denominator, so nothing here needs to change. This will stay as -1. Now I have a fraction divided by 1 fraction. I can go through and finish this by doing skip, flip, and multiply. We'll keep the top just how it is, y plus 2x squared over xy times, and now we're going to go through and we're going to flip this. So it's going to be x squared and a y at the top and y minus 1 at the bottom. And our goal from here is to see if anything will cancel. We can clearly see we have y's that cancel here. Here I've got 2 x's, here I've got 1, so I can get rid of one of the x's on the top, and I can get rid of the x on the bottom. The y minus 1 isn't going to cancel out here with this. The y's won't cancel because they're attached to plus and minus signs. So this is as far as this problem will go. So I've got an x and a y plus 2x squared here on the top, and on the bottom the only thing I have left is y minus 1. So the trick here is when you have these negative exponents, we're basically taking the negative exponent and putting it down in the denominator every time. You don't want to go through and work simple, complex fractions when you have negative exponents. You need to turn them into positive exponents.